I just wrote in all of the values from the procedure. Now, we should all have the same values because we all watched the same video. So as we're going through the calculations, I'm going to actually be doing the calculations with you because we all should have the same thing. So we have data and observations. So I'll just kind of show you what mine looks like. I have part 1. I do not have these temperatures or Q or C filled in yet because it didn't tell me to fill any of that in until the calculations. If I move down, I have data table 2, part 2, reaction 1. I have the information. And then here is my part 2, reaction 2, and part 2, reaction 3. Notice how every data table has a number and a title. Makes it easy to reference when every data table has a number. So I essentially filled up 2 pages for data and observations. So I'm going to go ahead and just start the next page for the calculations. I'm going to put the calculations page up here so that you can see it. This is the same calculations page. I'm on page 7 of the lab. So you have your lab handout. This is on page 7. For the calculations, remember that we're labeling every calculation. So we're going to label part that we're on, calculation that we're doing, but you only have to show one sample calculation. Now, number 1 tells us to graph something. So I'm going to go ahead and I'm going to flip in my lab notebook to where I will start the calculations section. I'll go ahead and label calculations. So calculations is our main header because it's a main section of the lab. Now, in the lab handout, it says that we have part 1. So I'm going to label each calculation with a subheading as well because we're going to have a lot of different calculations. So part 1 is heat capacity of calorimeter. So the whole point of part 1 of the lab is to determine what is C-cal for a styrofoam cup. So we're going to be doing all these calculations to find the experimental value for the calorimeter constant for a styrofoam cup. Ideally, it would be 0, but this isn't an ideal lab. We don't have ideal scenario. So for part 1, number 1 says to graph. So for calculation number 1, I'm just going to say C graph number 1. And we're going to make graph number 1 right now. I'm going to make it with you up on the board. So we're going to create a graph in Google Sheets. If you are not familiar with how to create a graph in Google Sheets, if you flip to the very, very, very back of the lab, I typed out a page that says how to create a graph in Google Sheets. This is literally step by step for making a graph in Google Sheets. I just did it this morning just to make sure that Google didn't update anything. So for this graph, it wants us to plot the part 1 data with temperature on the vertical axis and time on the horizontal axis. So on your Chromebooks, you can open Google Sheets. It's just sheets.google.com if you want to type it in. Chromebooks might have a shortcut somewhere. I don't know, I don't have a Chromebook. But sheets.google.com will bring you to Google Sheets. And we want to create just a blank Google Sheet. Okay, so I'll create a blank Google Sheet. I'm doing the same thing that you guys are. We're going to literally do the same thing in Google Sheets. But that way you make sure that you have the graphs. So I'm going to follow this how to create a Google Sheet. I'm going to follow this step by step. So it says enter your data in columns A and B. Enter the axis titles in row 1 and then the numeric data. Put what you want on the x-axis in column A and the y-axis in column B. So I want time on the x-axis. Once it stops loading, there we go. I'll zoom in for you so you can see what I'm doing a little bit better. There we go. So I'm going to put time in column A. I'm going to put temperature, which is degrees Celsius, in column B. This is part 1 data. So if I flip back in my data and observations to part 1, this is why labeling everything is so important. The time went from 20 seconds to 180 seconds. So 20, 40, 60. And if you're not familiar with Google Sheets, if you start a pattern, if you do a few numbers and you highlight those numbers, you have this little box in the corner, you can drag it down. It'll continue that pattern for you. So time is every 20 seconds up to 180 seconds. Then temperature. So again, we should all have the same temperatures. 43.4. So I'm just taking what was in my data table and putting it in Google Sheets. So again, I just took my part 1 data. So this is data table 1 that I'm putting in Google Sheets right now. So here's my data table 1 in Google Sheets. So now I have my data listed in here. And it says highlight the numeric data. Do not highlight row 1, so just the numbers. So to highlight, I'm just going to click on 20 and drag over everything. I kind of clicked in 20 and dragged over everything. And once you have it highlighted, you can insert your chart. You can insert your graph. So go to Insert up at the top. And then you have the option to insert a chart. There's also a button up in the toolbar, but you do Insert Chart. And, oh, I might need to zoom out to see it. Oh, there it is. So it inserted a graph. I'm going to move it over just so that we can see. So you can move it just by clicking in any of like the white space and moving it around. So it used to create a scatter plot automatically. If you look over on the side, it opens the chart editor. It created a line chart for me. I want a scatter plot. So what I'm going to do in the chart type over here is I'm just going to click. And I'm going to choose the second one, which is a scatter plot. I want each of the points individually shown. So in chart editor, make sure it says scatter chart. We want this scatter plot. So everything else should be defaulted. You have column A as the labels down here at the bottom. Now what we want to do is we want to make sure our titles are all accurate. We're going to be making 4 different graphs in this lab. Just like a data table, you need to make sure that your graph has a number and a title. So we'll do it together. So to add a title, we're going to now click on the Customize tab up at the top. All right, we have all these different options. I'm going to choose Chart and Axis Titles to change the names. So it automatically made it say temperature versus time for the title. I'm going to delete that. I'm going to make it say graph 1 because it needs a number, just like a data table. So graph 1, part 1, temp versus time data, right? Something like that. So I made sure that it's graph 1. It says that it's the part 1 data. If you're a little OCD like me, you can change the alignment to make it center right underneath. If you're like, I don't really care, then it's fine. But I always have to have everything like centered. You could change the color. You could make it bold or italicized. I don't really care. You should already have your X and your Y axis labeled. If for some reason you don't, you can actually click the drop-down menu and you can change the X-axis title, the Y-axis title. And so now we have graph 1. Now, if we look at this, it's going to be useful for us to have a trend line. So instead of having to try to figure out the equation for the line, Google Sheets will do it for us. So to find the trend line, we click on Series. All right, so if you click on Series and you scroll down, there's a checkbox that says Trend Line. So it draws that trend line for us. And if we want to see the equation for the line, you just scroll down a little bit more. And under Label, we can choose Use Equation. So now Google Sheets just gave us the equation of this line. And in here, it even says your temperature. So under step 6 on this, how to create Google Sheets, it says your temperature at time 0 is the y-intercept. So instead of having to do a calculation, they gave us one of our values that we'll be able to put in our data table. Now, step 7 says more than likely your y-axis is not going to fit this graph. So notice how all of our values are up here. We can actually change the y-axis to make our actual data fill the graph a little bit better. And so if we do that, so I'm going to close this menu, and I want vertical axis. I don't know why they renamed it horizontal and vertical axis and not X and Y, but Google decided that. So under vertical axis, we have this option of minimum and maximum. So we can change the minimum and maximum to make it fill our data. So the minimum, I'm going to do 42 because our smallest point on this is 42.6. I'm going to make my minimum 42. I could make my maximum, well, I could leave it alone. I'll just leave it alone. Could also make it like 44. If I made the maximum 44, I'd look like this. Oh, I don't want that. So this now lets us actually see our points. Pretty good points. So there's our graph. Here's graph 1. Google Sheets did it for us. So instead of making everything by hand, we have it like this. Now you can actually, what might be easiest since we will have 4 graphs, you have the 3 dots up here in the corner. We have a couple options here. You can actually download each graph as a PDF, but then you'd have to upload your lab and 4 different PDFs to Google Classroom once this lab is done. Or you can actually copy it and you can put it into a Google Doc. So let me show you what it looked like when I did this last year. I actually just would hit copy chart and I put my 4 graphs into Google Docs. So that way what you'll do when you turn in your lab is that you turn in your lab and then you turn in the Google Doc with all of your graphs. And so again, to do that, and we're going to be using this Google Sheet tomorrow as well. So we can copy everything over tomorrow if we need to as well. But you can click on the 3 dots up in the corner. You can just click on copy chart, open a Google Doc, and you can then paste your graph in there. Now, since we will be using this Google Sheet again tomorrow, you want to make sure you can find it easily. So I would actually name the Google Sheet. So like I'll name this Thermodynamics, Thermodynamics data, right? Or you could make it Thermodynamics graphs, something like that. And then another useful thing to do, since we want to put all of our graphs in one Google Sheet, if you want to make it easy to find everything, we can actually make every set of data a different sheet down at the bottom. So down here at the bottom where it says sheet 1, you can click on the little arrow, or you can like right click and you can choose rename. So I could actually rename this part 1 data. And then tomorrow we'll actually look at part 2 reaction 1, part 2 reaction 2, and part 2 reaction 3. So then we'll have 4 different tabs in the Google Sheet. Now, this is all we want for now. So I'm going to leave this here. I'm going to switch back so that you can see my calculations, and I'll kind of flip back and forth to this when needed. All right, number one, we said see graph 1. That's why it's important to have numbers, because when you say see graph 1, I can look at all your graphs and say, see it, got it, you're good. Now, calculation number 2 says the first few points might be erratic due to incomplete mixing. Draw a straight line. Extend the line back to time 0. Record this temperature as T mix in the part 1 data table. Well, Google Sheets did that for us too. So here's what I'm going to say for number 2. I'll say see graph number 1 for trend line. And data table number 1 for T mix. So we're going to go back. See, now that we're getting into the calculations, now we're going to fill in some of those variables that we labeled underneath the data tables yesterday. So Google Sheets did our first 2 calculations for us. So here's what I need to do, because I said see data table number 1 for T mix, so I need to make sure that I fill in T mix. All right, need to make sure I don't write through all my pages. Flip back to my data table number 1. So here, T mix, this was our y-intercept. Y-intercept for this graph is 43.5 degrees Celsius. All right, so again, I'm going to show you, I'm not going to write it in here because I want to use this for every class. T mix. We are under data table 1, part 1. Right underneath data table 1 in your data and observations is T mix. T mix is 43.5 degrees Celsius. T mix is 43.5 degrees Celsius. Okay, so I'm going to flip back to my calculations section. And calculation number 3. So now we're getting into our calculations. So now that we're actually calculating, we have to make sure that we label our calculations. It says calculate the average initial temperature, T average, of the hot and cold water. Then record the temperature in the part 1 data table. So I'm going to start by labeling my calculation. So number 3, we're calculating T average. Now, it's simply that, it's an average. Now in part 1, we had hot water and cold water. So this T average is my label. So over here, I'll do the calculation. T average. We're averaging the hot and the cold water. So I'm going to do the temperature of the hot water plus the temperature of the cold water. If I want to find the average of these, if I have 2 numbers, what do I divide by to find the average? So temperature of the hot water plus temperature, I guess I said cold water, but it's the room temperature water, and divide by 2. So I'm going to go back to my data. This is all part 1, so my entire focus should be this part 1 data. So hot water was 68.8. Room temp was 22.3. So 68.8 plus 22.3 divided by 2. 68.8 plus 22.3, 91.1 divided by 2, 45.55 degrees Celsius. You just have to be careful with order of operations. So I did 68.8 plus 22.3 first, then divided it by 2. And then in calculation 3, it says record this temperature as T average in part 1 data table. So flip back to part 1, T average. All right, so T average is 45.55 degrees Celsius. So we're in part 1. So we're in part 1, right underneath the data table, T average, 45.55 degrees Celsius. So all of these variables underneath are the results of our calculations. So we're able to just put everything in one location. Right, so then calculation number 4. Calculation number 4 says the difference between T average and T mix is due to the heat lost by the water and absorbed by the calorimeter. The heat lost by the water. So I want you to keep that in mind. It keeps telling us that water is losing heat. That means that the value of Q for water should be what if it's losing heat? Negative. So we should see a value of Q of H2O being negative. So the heat lost by water is, and they even give us the equation, grams of water. So MC delta T. Now our delta T is a little bit different for this because we had the hot and the cold water. So we're going to do T mix minus T average for our delta T. And it says where specific heat of water is 4.18. And then it talks about the heat gained by the calorimeter is equal to that lost by the water, but opposite in sign. Calculate Q cal. All right, so before we calculate Q cal, it wants us to calculate Q of H2O. So I'm still going to label this calculation Q cal, because that's what the question is asking for. You always want to label your calculations. So I'm going to start over here by solving for Q of H2O. And it says that we need mass of water, specific heat of water, and delta T. Now the mass of water is a little bit different because we didn't put it on a scale. We had 50 milliliters of hot water and 50 milliliters of room temp water. So we have 100 milliliters of water. What's the density of water? 1. So 100 milliliters is 100 grams. The density of water is 1 gram per milliliter. So 100 milliliters in lab is 100 grams. So right now I'm calculating Q of H2O. So 100 grams wants us to just use 4.18. And then again, for delta T, it told us to do T mix minus T average. So I'll look up those values. Oh, wait. Just to make sure, and then I'll put them in here for us. T mix, 43.5 minus T average is 45.55. So the reason that this Q is different and that we're using different variables for delta T is because of us mixing hot and cold water together. That's why it gives us the equations to use. So 100 times 4.18 times 43.5 minus 45.55. So Q of H2O, negative 856.9 joules. There's Q of H2O. Again, the reason we got these numbers, T mix was our y-intercept. This was T average, which was from number 3. So just in case we're looking back at anything. So Q of H2O is negative 856.9 joules. The water released 856.9 joules of energy, like joules of heat. In the calculations, it says the heat gained by the calorimeter is equal to that lost by the water. So what is Qcal? How much heat does the calorimeter gain? It's going to be this, just positive. And so since it says the heat gained by the calorimeter is equal to that lost by the water, that's because if we remember the first law of thermodynamics, first law of thermodynamics says heat is neither created nor destroyed. So all of the Q's always have to add up to equal 0. Follows the first law of thermodynamics. So the fifth and final calculation for part 1 says calculate the heat capacity of the calorimeter. So my fifth and final calculation for part 1 is calculating Ccal. And, we'll transfer both of them at the end. So it says this is equal to the heat the calorimeter absorbs when 100 milliliters of solution changes 1 degree in temperature. So notice it has nothing to do with mass. It's just the heat when the calorimeter changes by 1 degree Celsius. And so it even shows us how to calculate it in the lab. Qcal, so the heat absorbed by the calorimeter, divided by T mix minus T initial, where T initial is the initial temperature of the cool water. That's the room temperature water. And then record the heat capacity in the data table. So Ccal, I'm just going to rewrite this so as we plug numbers in, T mix minus T initial. So T mix, if we remember, is our y-intercept. T initial is for the room temp water. Now I'll go ahead and I'll plug my numbers in. Qcal we just solved, 856.9 joules. The calorimeter absorbs 856.9 joules when it changes by a certain amount. So our y-intercept, our T mix, was 43.5 degrees Celsius. T initial, so our initial temperature of our room temp water is 22.3 degrees Celsius. So if I put this in the calculator, watch how I put it in the calculator. 856.9 divided by parentheses 43.5 minus 22.3. If you don't use parentheses and you do it all at once, it's going to give you a different answer. So the heat capacity of the calorimeter, 40.4, we'll use 4 sig figs, 42 joules per degree Celsius. 40.42 joules per degree Celsius. So for every 1 degree Celsius that the calorimeter changes, it absorbs 40 joules of heat. Now we want to make sure that we get Qcal and Ccal copied into our data table. So if we flip back to part 1, Qcal was 856.9 joules. Qcal was 856.9 joules. And Ccal, calorimeter constant, was 40.42 joules per degree Celsius. So now we have all of part 1 completed. We have the data table filled in. We should have all 4 of these variables filled in. That came from our calculations. So part 1 calculations are completed. We will go through part 2 and part 3 calculations tomorrow. So we'll go through, we'll graph everything again. We'll go through the calculations. But I wanted to make sure we at least got the part 1 calculations done today.